quick history of the Internet. On October 29, 1969, an organization called ARPANET, also known as Advanced Research Projects Agency, launched the first iteration of the Internet, connecting 4 major computers at 2 universities. When this network of computers was connected, universities were able to access files and transmit information from one organization to the other, as well as internally. As researchers developed the system, they continued to connect computers from other universities. Eventually, ARPANET was renamed Internet. In 1991, the University of Minnesota developed the first user-friendly Internet interface, making it easier to access campus files and information. Well, now let's know how is the Internet functioning. You now see the video. You've journeyed about 1,000 miles from a Google data center. Let's learn how the web works by understanding the details of this incredible journey. Your video has been stored inside the data center that is 1,000 of miles from you. How do your mobile or laptop receive these data? The use of satellites would be an easy way to achieve this goal. The satellite could receive a signal via an antenna from the data center. And then a signal from the satellite can be sent via a nearby antenna to your mobile phone. But it's not a good idea to transmit this signal. See why the Earth equator is almost 22,000 miles above the satellite. To successfully transfer data, the total distance of 44,000 miles must therefore travel. Such a long journey causes a large delay when the signal is received. In particular, it causes huge latency, and for most Internet applications this is unacceptable. So if you don't receive this video via a satellite, then how do you get it? Well, it's done through a complex optical fiber cable network connecting your data center and device. Your telephone may connect via mobile data or any Wi-Fi router to the Internet. But your phone will ultimately be connected to this fiber optic network at some point. We found that the video you are viewing is stored in a data center at the beginning. In addition, it is stored within the data center on a solid-state device. This SSD serves as the server's inner memory. The server is simply a strong computer that has the job of providing you with video or other content that you want. The challenge now is how data stored in the data center, in particular, can be transferred through the complex optic fiber cable network to your device. Let's look at how it's done. We must first understand a key idea, that is the concept of an IP address that is uniquely identified with a number string known as an IP address by any device which is linked with the Internet, whether it is a server, computer or mobile telephone. The IP address can be considered as your home address. This is the address that identifies your place of residence. Any correspondence sent to you is reachable by your address precisely. The IP address acts as a shipping address for similarities in the Internet world, through which all information reaches its destination. The IP address of your device will be chosen by your Internet service provider, and you can see what IP address your ISP gave to your mobile phone or laptop. There is an IP address on the server in the data center. The server saves a website to access any website simply by knowing the IP address of the server. However, many IP addresses are difficult for a person to remember. To resolve this issue, domain names such as youtube.com, facebook.com, etc. are used that match IP addresses that we can remember more easily than the long sequence of numbers. Another noteworthy thing here is that a server can store multiple websites. And when there are several websites on the server, the IP address for the server cannot be accessed to all of the websites. In such cases, the website will be identified with additional sections of information host headers. However, the entire data center infrastructure will be dedicated to storing the particular website for giant websites like facebook.com or youtube.com. In place of complex IP address numbers, we always use domain names to access the Internet. Where does the Internet receive IP addresses that match our domain name requests? The Internet uses a huge telephone book called DNS for this purpose. You can look up in a phone book if you know the name of a person but do not know its telephone number. The DNS server provides the same Internet service. The DNS server can be run by your Internet service provider or by others. Let's have a recap of the entire surgery. The browser will send the request for the appropriate IP address to the DNS server. Your browser will simply forward the request to the data center, specifically, to the respective server, after receiving the IP address. The data flow will be transferred in digital format by means of optical fiber cables once the server receives a request to access a particular website. In particular, these pulses must sometimes travel 1,000 miles through the optical fiber cable to their destination in the form of light pulses. They often have difficult terrains like hilly areas or under the sea to travel during their journey. These optical cable networks are built and maintained by a few global firms. These visuals illustrate how a ship can lay optical fiber cables. Deep into the sea, the plow is dropped from the boat. And this plow creates a seabed trench and places the fiber optic cable with two witches. Indeed, the Internet is the backbone of this complex optical cable system. These light-carrying optical cables are spread across the seabed to your door and are attached to a router. This light signal is converted into electronic signals on the router. The electrical signal is then transmitted by the Ethernet cable to your laptop. When you use cellular data from the optical cable, however, you have to send the signal to your cell tower. In the form of electromagnetic waves, the signal reaches your cell phone from the cell tower. As the Internet is a global network, a company must manage things such as IP address, assignment, domain name, registration, etc. All of this is managed by ICANN, a US-based institution. The efficiency and data transfer in relation to cellular and fixed communications technologies is amazing. One thing about Internet. You are sending this video in the form of a massive collection of zeros from the Google data center. It is the way in which these zeros and zeros are cut into small chunks called packets and transmitted that makes data transfer in the Internet efficient. Assuming that these zero streams, each of which consists of 6 bits, are divided into various packets by a server, together with the video bits. The sequence number and the IP addresses of the server and your phone will also be included in each packet. The packets are routed to your phone with this information. All packets must not be routed along the same track, and each packet takes the best available route independently. The packets are reassembled by their sequence number when you reach your phone. If any packets have not reached your phone and a message is sent to resend the lost packages from your phone. Compare this with a good infrastructure postal network, but customers do not follow the essential rules for destination addresses. Letters cannot reach the right destination in this scenario. We use something known as protocols to manage this complex flow of data packets in a city similarity on the Internet. The protocols specify rules for the conversion of packets, the attachment of source and destination addresses to each packet, and rules for routers, etc. We hope this video will help you to understand how more specifically the Internet works on the great adventure of data packets from the data center to your handset. Well, today's Internet usage look like it's estimated that 3 billion people now use the Internet, many of whom use it on a daily basis to help them get from point A to point B, catch up with loved ones, collaborate at work. As technology changes and the Internet weaves its way into just about every aspect of our lives, even more people are expected to use it. In 2030, researchers project there will be 6.0 billion Internet users and 400 billion devices connected to the Internet.
Thanks for watching. Hit the subscribe button if you like your video and don't forget to click on the bell icon, which will get you notified of our next videos.